All right, so today we're going to do a lesson on graphing quadratics, and it's probably the first time we're actually going to. If you did the lesson yesterday or the previous lesson, you kind of just played with the variables, right, to see what they did, right? Now we're going to get kind of more detailed, okay? I think the best thing to do right now is just put everything down, just watch for a little bit, all right? I'm going to change that. There, I like that one. All right, so that we got this graph, yeah? We're going to talk about some of the characteristics of this graph. So you don't need to be doing anything right now. What you need to do is just pay attention to this. All right. First things first, probably the most important thing on the graph is that there's going to be this imaginary line that goes right down the center of the graph. All right? Anyone knows what that's called? Yeah, go ahead. This is called the axis of symmetry. What does symmetry mean?
Oh, same on both sides.
Right, symmetrical, right? What you're going to notice, and that's why these are so easy to graph, is once you find a point over here, you can find the other point over here. For example, if this one's like 3 this way, this one's going to be 3 this way. If this one's 1 this way, this one is 1 that way. So you can reflect them really quick. All right? That axis of symmetry, the way you find it is you do negative b over 2a. I cannot explain to you right now at a Algebra 1 level of why that formula works. You see part of this formula when you do the quadratic equation? Yeah? Negative b plus or minus the square root of b squared minus 4ac over, what was it? 2a. There's the negative b over 2a part, yeah? All right? It really goes back to, if you want to really look into where it comes from, you're finding the first derivative of the equation. And you're like, what's that exactly? You'll learn that in calculus. It's really not hard to understand once you understand what a derivative is, but we're not going there right now. Right now, you're just going to have to take it. Negative b over 2a, yeah? All right? So once you do negative b over 2a, you will get this imaginary line. And it'll always be x equals some number. So in this case, what is it? X equals negative 2. Yeah? And then somewhere on that line will be this point. Anybody know what that point's called? This is it is a minimum, but it's called the vertex. And it's either the top or the bottom of the graph. Yeah? When would it be the bottom of the graph? When it's x squared plus a positive number here.
Oh, yeah.
If it was a negative number there, we learned this the previous lesson, right? That would make it go like this. This would go like this. So it would have a minimum, yeah? This wouldn't have a, what do you think? Maximum. Pretty logical, yeah? How to find where the vertex is takes a little bit of work, and we're going to do that in a few minutes. And then there's one other point that we're going to, well, 2 more points that we care about. This point we care about. What is that point?
Y-intercept.
That's the y-intercept. It's going to be really easy to find, because if you go to your notes, whatever c is going to be the y-intercept. Well, why would that be true? Because what do I know about every y-intercept? X is 0, right? So if I make this 0, and I make that 0, that'll just be 0 times something that's 0 plus 0 equals c, or plus c. So whatever c is going to be the y-intercept, just like every other problem we've done, yeah? You with me on that? And then tonight we're not going to do this, but the next lesson we are, you're also going to have these 2 points. This point here and this point there. Anybody know what those are? Zeros, and that's another name for the what? That's the x-intercepts, right? We're not going to graph those tonight, but they're the x-intercepts. Those are all the main characteristics of a quadratic, yeah? What do you think the most important part of these graph is? What starts the whole thing? Starts the axis of symmetry. We're going to change it to axis instead of line. When I first did this, I called it a line of symmetry, right? But change that to axis of symmetry, please. If you get the notes later on, I probably are going to fix it in the notes. Also here too, right? Axis of symmetry. All right. Tonight's assignment is really about labeling everything. Yeah? Label everything that you write down. The more you label it, if you get your flashcards out that you're going to start using to get ready for the STAR tests, on there is one of the first flashcards is the labeling of this picture, knowing where everything is. If you already know where they are, that's 50% of the battle already. Yeah? All right. So let's do a problem. First thing, change this to minus 10. I think it's a lot better problem if it's minus 10. Okay, so just looking at this for a minute, what do I know about this graph? What do you know? Okay, the y-intercept is going to be negative 10. Okay, what else do I know? It's going to be a sad face. Why is it going to be a sad face? Because this number is negative. Remember what we did last night, or the previous lesson? That's negative. So it's going to do something like this, right? And then it's going to cross down here at negative 10. Yeah? We're not going to sketch that right now. We're actually going to find out exactly where it is. But we should be getting something like that. All right. First thing we're going to find is the axis of symmetry. It's going to be, start writing it every time. Negative b over, what was the formula? 2a. And then all we do here is we just plug in the numbers. The negative of what? Come on, everybody. Negative of 12, because that's a, that's b, and that's c, right? Negative of 12 over 2 times negative 2. So that's negative 12 over negative 4, which is 3. All right? So what you do is you go to x is 3, which is right here. You make a vertical line. And what is that line called?
Axis of symmetry.
Axis of symmetry. Okay, so label it. Axis of symmetry. And where is it? It's at x equals 3. And then we need to figure out one other thing right now. Oh, no, we're not at the vertex yet. We'll get there in a minute. Okay, pretty simple. Okay, now the next thing. Somewhere on this line is the vertex, right? Maybe it's here, maybe it's here, maybe it's here, maybe it's here. I don't know where yet, yeah? But somewhere on that line is the vertex. You guys get that? Yes. All right. Well, how do I find out where that point is? What you do to find the vertex, you know it's going to be at 3, comma, something, right? Any ideas of how to find that something? What do you got? Nope, that's not going to give me the vertex, though.
You see how far that one is away from the axis of symmetry?
No, actually, that 3 is on that axis 3 is on this line. So it is this line. You know it's somewhere on this line, right? I don't know where, but it's on this line. Anybody else? Let's go back to linear equations. If I told you the x coordinate, couldn't you find the y coordinate? Right? Right, don't copy this, but if I had y equals 2x plus 1, and I told you x is 3, what's y? 7. What'd I do? Plug it in, and that's all you're going to do here. You're just going to plug it in. So we're going to plug it in. Y is going to be equal to what? Negative 2 times 3 squared plus 12 times 3 minus 10. Got it? All right. Do the math for that. What is that? 3 squared is 9 times negative 2. We get negative 18 plus 36 minus 10. So what is that? That's negative 28 plus 36 is 8, I believe, right? 8. So it's 3/8. So I go to 3/8. That's this point right here. That's 3/8, right? Notice it's on the axis of symmetry. What is this? What's this called? That's the vertex. And it's at 3/8. And then my other question, is it the minimum or the maximum of the graph? How do I know it's a maximum? Because this is negative. It's going to be a sad face, not a smiley face, a sad face, which means it'll be the top of the graph, right? So it's doing something like this, yeah? All right, so that's a maximum. So write maximum. Okay. Now, what other point can I graph right now? The y-intercept. I already know it's at negative 10, so it's down here. Yeah? That's going to be the y-intercept, right? The y-intercept is negative 10. The second I graph the y-intercept,
You can do the 3 boxes.
Right. Look, what he just said is correct. You're 1, 2, 3 away. So you're 1, 2, 3 away. So there's a point over here. They reflect. They're symmetrical. Yeah? Okay, now watch this. You now know what this graph is looking like, right? It does something like this, right? But you don't know exactly how yet. Yeah? So what you're going to do is look at some points that would be useful to know. Well, x is 1 and x is 2 would be good points to know, wouldn't they? Because if I got x is 1, it's going to be somewhere around here. Yeah? And that would be a good point to know. That would help us to flesh out the rest of the graph, right? So we're going to then make a table for the rest. And you can do this table however you want to do this table, okay? So I'm just going to do 2 more points. Because every time I make 1 point, I actually make 2 points. Do you know that? Right? So I'm going to try 1. And once I find 1 whatever, I know another point. So 1, let's just plug it in. We can almost do this in our head. 1 squared times negative 2.
Negative 2.
Negative 2 plus 12 is 10 minus 10, 0. We actually just found an x-intercept. Didn't we? 1, 0 is an x-intercept. All right, so we got that point. 1, 0 is an x-intercept. Yeah? If I know that point, what other point do I know? 1, 1, 5. Yeah? I know 1, 5. And that's probably enough to get the graph. But I can put 2 in also just to have another point.
How do you know 1, 5?
1, what did I graph? 1, 0. Oh, I just did the opposite. What should I have graphed? Good catch. 5, 0, yeah? 5, 0. Yeah, that's this point. 5, 0. Good catch. That was not on purpose. All right, let's do 2. 2 squared times negative 2. Negative 8 plus 24. 16 minus 10. 6. 2 6s on the graph. All right, 2 6s on the graph. 2 6 is here. Reflect it, which would be 4 6, right?
Yes.
All right, and that's enough to graph it. What I don't want you to do, please pay attention to this. I do not want you to make a V here. If you make a V there, I'm going to count it wrong, okay? I need you to U-shape it out because it's going to be a U-shaped line, so kind of flesh it out a little bit, yeah? And if you go over it, you don't have to be exact here. I didn't say get out a straight edge, yes? Because it's curving the whole time. You really can't. So it's doing something like this and something like this, right? Make sure you label everything. I labeled the y-intercept. I labeled the axis of symmetry. I labeled the vertex, minimum, maximum. Yeah, that's everything. Tonight we're not going to label the x-intercept, but you did find them, right? That's the x-intercept. Yeah? Got it? Now that's a lot of talking, but it's really not that hard because once you find the axis of symmetry, everything else just falls into place. Yeah? All right, let's try it again. First thing we find? All right, axis of symmetry. Formula?
Negative t over 2a.
Over 2a, good. All right, the negative of?
Negative 6.
The negative of negative 6, which is 6, over 2 times 3, which is 6, so that's 1. The axis of symmetry is at 1, yes? So I'm going to put a, why is it a dotted line?
Because they aren't.
It's not really there. You can actually force a calculator to show you the axis of symmetry. I don't think they disable it during the test. I'll show it to you later. All right. Label that. Which way is this pointed? Is this a happy face or a sad face?
Happy.
Happy face. So I'm going to label it up here, right? That's the axis of symmetry. You can abbreviate it a little bit. I don't mind. X equals?
Wouldn't you label it on the bottom?
No, because it's going to be a happy face, so it's probably going to be down here somewhere, yes? So if I label it down there, I'm gonna write the vertex down here. I don't care where you write this. It's not that big of a deal. I'm just trying to give myself room, yeah? What was the axis of symmetry?
1.
And start writing it every time x equals 1. It'll get stuck in your head that the axis of symmetry is x equals something, not y equals something. Yeah? And then on the test, if you had this on a test question, you'd know automatically axis of symmetry is x equals something. You throw out two answers because probably two of them is y equals something. So, all right. So far, so good. Now we're going to find the vertex. The vertex is at some point 1 comma something, right? What do I do with that 1? Plug it in. So I get y is going to be equal to 3 times 1 squared minus 6 times 1 plus 2. 1 squared, 1, 3. That's 3 minus 6 plus 2. Is that 1? Negative 1? All right, so it's at 1, negative 1. So there's my vertex, right? I'm going to label that. Vertex is at 1, negative 1. If you don't label tonight, then they're going to have to just eyeball it to try to figure out what you had. And if they can't figure it out, it's wrong. Minimum or maximum? Because I know that's going to be the bottom of the graph because this is positive, right? So it's going to be a minimum, yeah? Minimum? Where's my y-intercept?
2.
2. So I'm going to go to x equals, or y equals 2, which is right here. Can I reflect it? What point do I know is on the graph because of that? 2 comma 3. Yeah, so that point's on the graph. And then what point would you check now to get some more points on the graph? We already know 1. 1's the axis of symmetry, right? I would actually check the next point over because these get vertical really quick usually. I would check either 3 or negative 1. Yeah? I'm going to do negative 1 because it's usually easier to square negative 1 than it is the other way around. So I'm going to do negative 1, right? All right, negative 1 squared
1.
times 3
3.
minus 6 times negative 1.
9.
9 plus 2? 11. Yeah? I'm already off the graph, aren't I? The graph that I have here, I'm already off. So it's a little bit above the graph, right? So it's a little bit above. Can I reflect that?
Yes.
What other points on the graph for sure?
3.
311. I want to make sure you understand why 311's on the graph. Okay. Do we make a V-shaped line?
No.
No, U-shape it out, yeah? Spend a little bit of time there making it U-shaped. And then just connect it. And my screen has a hard time drawing a straight line. But try to make that as straight as you can, yeah? All right, did I label everything?
Not the y-intercept.
Not the y-intercept. What was my y-intercept? 2, right? All right, so I'm going to label it.
So we have to label the y-intercept, axis of symmetry, and vertex.
For tonight, yes.
And then minimum and maximum.
We got everything else, right? And we could estimate where the roots are, where the zeros are, right? We know that zeros are going to be between 1 and 2, right? The zeros will be somewhere between here and here, right? So I know it'd be somewhere around that. I don't know exactly, right? It probably won't be pretty, so. All right, last problem. Definitely change this one to this, okay? So change this to 1/2 x squared minus 4x plus 4. When I did this problem with the regular numbers, the y-intercept ends up being like 38 or something. So a little bit above the graph.
I'd say so.
All right. All right. Step 1.
It's going to be a sign.
Axis of symmetry. Without my help, see if you can write the formula without looking at anything. Do you get negative b over 2a? I don't think that's given to you on a formula chart, so it's something you have to know. I might be wrong. All right, find the axis of symmetry, please. You get 4? Half of 2 is 1, right? Why is it 4 and not negative 4?
Negative 4.
It's the negative of b, so it's the negative of negative 4, which is 4. All right, graph your axis of symmetry, please. And the equation of the axis of symmetry is always what? X equals some number, so x equals 4. If you know all these pieces already, so if you're already learning what these pieces are, you already know the flashcard. What is that, card 6 of your flashcards? You already know it, yeah? All right, now let's do the vertex. We know it's at some point. What's the part of the point that we already know?
The X. 4.
The x. So we know it's 4,
Comma,
4 comma something, right? All right, plug in the 4. I think I made this pretty nice numbers. Half of, I might write this, I'm gonna write this one out because this take a little bit of work, right? Minus 4 times 4 plus 4, let's see. 4 squared is 16, half of 16? 8 minus 16 plus 4? Negative 4, right? So negative 4. So it's at 4, negative 4. All right, 4, negative 4. That's a vertex. Label it. All right, it's at, make sure you label everything so that we don't have to count ourselves. And 4, negative 4, what is it?
Minimum.
Okay, someone explain why it's a minimum.
It's a happy face.
Because A is positive, which means it's a happy face. Yeah? So it's a minimum. All right, what other point should I put down right now while I have a chance? Y-intercept. Y-intercept's 4. So go to y equals 4. There's a point there. What other point do I know is on the graph then? 8, 4, right? Okay, stop there real quick. Does everybody understand why 8, 4 is on the graph? Questions? All right, good. All right, what other 2 points should I track? I would actually probably try to check things around here. Yeah? Something around there. So maybe 3 and 2? Yeah? I might want to check negative 1 because maybe I don't know what it's doing over here. You want enough that you can get a good picture of it. So I'm going to check 1 real quick. Let's check 1. I think we can do the math. Ew, I don't want to do 1 because I'm taking half of it, right? So let's do 2. All right, so 2 squared is 4, half of 4. 2 minus 8. Negative 4 plus 4. Wait. 3 minus 8 is negative 5 plus 4. Did I do that right? All right, let me just do it. 1/2 of 2 squared minus 4 times 2 plus 4. Yeah? That's 2 minus 8 is negative 6 plus 4 is negative 2. All right, negative 2. 2, negative 2. What other point do I know then?
6, negative 2.
6, negative 2. Now let me show you something cool. There's a bonus piece. If you see 2 points on the same y, yeah, then you know those 2 points were being reflected, right? So if you know, I've seen this asked before on tests, and people don't know how to do it, but it's so easy. If I know those 2 points, I know they're across from each other, right? I can find the axis of symmetry, exactly. Why? Because it would be halfway between them. So if they ever give you 2 points, you can find the axis of symmetry if those 2 points are horizontal to each other. It would not work with vertical points, obviously, but it would definitely work with horizontal points, yeah? I would say what's halfway between 6 and 2? 4, which is what we got, yeah? All right. And probably check -1. I'd probably check -1. That would give me a point that might be helpful. How about -2? Yeah? Because I don't want to take half of that. So let's see. -2 squared is 4. Half of 4 is 2 minus, actually plus 8, right? So that's 10 plus 4. I'm already off the graph, yeah? So I'm way off the graph. 10, 11, 12, 13, 14. So somewhere around here. And then what is that? 1, 2, 3, 4, 5 away. 1, 2, 3, 4, 5 away. Way up here somewhere, yeah? And that's enough, right? I probably, if that point was already off the graph, you wouldn't have to graph it, yeah? All right, U shape it out. Don't make it a V. So spend some time there making it a U shape, yeah? And then just connect the dots. Yep. That half is flattening it, right? It's compressing the graph. All right, did I label everything? Missing some stuff. Y-intercept is what? Is 4, right? Or 0, 4. That's either one I'd accept. You can kind of estimate where the roots are, where the zeros are, right? One of my answers is between 0, 1, and 2, and my other answers are, looks like between 6 and 7. Don't do it. Stay away from it. People in the future, you may not know this 10 years in the future, but this generation of idiots thought when you say the word 6 and 7 together that it's the coolest thing since, I don't know, Kool-Aid was invented. You can't see right now, but they're all like, oh, I love Kool-Aid and 6 and 7. Each generation has their stupid thing. What was my generation's stupid thing? Parachute pants. I had a pair of vinyl parachute pants that were so cool looking, only you wore them and you sweat incessantly. They were horrible. Everybody, ever seen that episode of Friends when Ross wears the leather pants and he has to go to the bathroom and he can't get the pants back on? It's a funny episode. Anyways, has nothing to do with this. Make sure when you do this, the key is the axis of symmetry and everything else falls out of that, yeah? All right.